All right, so you're going to need your graphing calculators. So whoever is in charge of the video, go ahead and pause it. And everybody get out your graphing calculator, and you've all got the worksheet in front of you and something to write with, of course. So pause it if you need to. All right, let's go ahead and get started. So as it says, using your graphing calculator, go ahead and graph this. And it's suggesting that you change the X window to 0 to 10. So everybody take a moment, pause the video, do that, and then resume the video when everybody's got that going, okay? Okay, so what you should see then is a kind of a curve, a steady curve kind of up, but maybe it looks like it kind of flattened off a little bit. All right, so make sure you sketch that. So here's what I see since I still had -10 to +10 on my Y values, but it says to go from 0 to 10, so this is 10. And it starts at the origin, which I imagine that if I was raising this whole thing to the 0 power, or it actually starts at 1. Because if I raise the whole thing to the 0 power, it starts up at 1. And it does this, and I don't really know. I'm imagining it's going on forever because I can keep putting in different values. Okay, so then how about changing the window like it states to go from 0 to 10,000, and you're only changing the X window. Leave the Y's at -10 to +10. So pause again and give that a try. Okay, so you probably see that it looks like a horizontal line. It looks straight across. So what's really happening there? What do you think is happening? So you can pause and discuss if you like. Okay, so yeah, we have a straight line, but what's happening is it must be leveling off at some point. It must not have a height that it's not going to continue to grow higher, even though the X's will continue to go on. So could it be an asymptote? Could it be just that it just barely rises? Is this a form of end behavior? Kind of interesting. So next thing we're going to do is we're going to take a look at certain values in the table. And as it suggests on the worksheet, you're going to go to the Ask feature, which is under Table Set. So second window. We've done it lots before. But just go ahead into there and just make sure it's on Ask, and then change your X's to those values, 5, 50, 500, and 5,000. And you can even go another level if you want to take a look at 50,000 and see what happens. And you can see what's happening with your Y's. So go ahead, take a moment, pause the video, and write down those Y values and take a look at what they are. So as you can see, they're kind of they're increasing, of course, right? But then they end up, like if this was a 0 here, right? So then they end up at 2.7183. So based on the values in the table, it does look like a horizontal line, but they are increasing in value. So keep going in your table, and well, we kind of already skipped all the way to 50,000. So I want you to go back, so you can kind of ignore this table because we already kind of took care of it there, but you're welcome to fill the values in. Go back to your home screen, and I want you to press e to the 1 power. And the value e is actually found on your calculator in 2 places. I'm going to write down those places for you. If you want an e to the x, so if you want to actually put in an exponent, that's found on second, and it's the LN button, which is located by the number 4. The other place is if you just want the e, and then if you choose to put in an exponent, that one is found on second division sign. So both places have the letter e, and I say letter because we think of it as a letter, but it's actually a number. And if you press enter, which on e to the first, or if you just use e, you end up getting 2.718281828. Now, what we have here is what might look like a pattern, and you might go, oh, I bet it's another 8-1. Well, it isn't a pattern, and this is an irrational number, meaning it has no pattern and it does go on forever. Like pi, there's no pattern in pi, and it is non-terminating. So here it is, this goes on forever. Well, then what do we have? Well, we have what we call, as x is approaching infinity, we have the number e. And e is Euler's number, and the natural base e. So we will use this as a number from this point forward. I want you to definitely pause because you don't need to wait for me to do these next ones here. I want you to pause and I want you to try numbers 7 through 18. On numbers 7 through 15, however, you are not finding a value. You are just simplifying by using all of your exponent rules that you know. I do not want you to evaluate. I want you to save that step for numbers 16 through 18. So again, do not press the buttons in your calculator for numbers 7 through 15. Just work with the exponents and simplify those. However, for numbers 16 through 18, please use your calculators and evaluate them to find a numeric value of e to whatever power that is. So pause, take a couple minutes. Whoever's in charge of the video, make sure everybody's got some time to do it before we play the video again. So here it is, it says, you buy your first new car. Your purchase price is $25,000. Cars depreciate at a rate of 6% per year. How much is your car worth in 4 years? Well, the first thing is we're going to set up a model. And the model we're going to use here is A equals P times 1 plus or minus the R to the power of T. This is not an interest problem, so we're not using a compound interest formula. So it says I'm going to start with the 25,000, and because it depreciates, I'm using subtraction. It says 6%, so I use 0.06, and it says 4 years, so I use 4. So I'm going to go ahead and substitute all of those values in. Once you do that, you have actually solved the problem and found out how much your car is going to be worth in 4 years. So pause the video, whoever's in charge, and go ahead and let everybody go ahead and calculate that, and then resume the video so we can check with each other. All right, so in 4 years, the car's value is $19,518.72. You don't need the extra decimal places because it's money. Okay, go ahead, let's try the next one. And again, if somebody needs you to pause, please pause. Okay, you buy a valuable stamp collection for $3,000. Each year the value of stamps increases. So here it wants us to go ahead and set up the model. That is, that it says the value. So we're going to use y equals, V is the value, that's $3,000. And it's going to be increasing, so we're putting in the 0.05 with a plus sign to the power of t years. Now, what is it worth in 15 years? So it says take this and actually solve it. Why don't I just write 0.05 to the 15th power? Pause the video, let everybody have a chance to type that in their calculator. All right, the stamp collection is worth $6,236.78. Okay, let's try another one. A city's population grows exponentially. In 3.5 years, the population grew from 12,000 to 14,000. But this time it's asking us to find the rate. So it does not give us the rate, it's asking us to find the rate. Well, if the end result is 14,000, and we currently start with 2,000, and it says 1 plus r, because it's growing, to the 3.5. So we have to work backwards to figure out the rate. So to do that, I'm going to start by dividing by 12,000 because that's going to help me get the base all by itself. So if I divide by 12,000, I get 14 over 12 equals 1 plus r to the 3.5 power. Now to get rid of an exponent, we use radicals. To get rid of this exponent, I basically have to take the 3.5th root. I don't know what that is. So I'm going to use 14 over 12 to the 1 over 3.5 power equals 1 plus r. So pause in your calculator, pause and use your calculator to find this. Okay, so what you notice is you come up with a 1.045, but I still have to subtract 1. So when I subtract 1, I get the, well, what you should get is 0.045. Now, if you are unsure how to convert that to a percent, by just looking at it, go ahead and just multiply by 100, and it tells us that it's 4.5%. So 4.5 is the rate. It wants us to use that to find the population in 6.5 years. So I'm going to go back and I'm going to say I don't know what the population is later on, but I do know that I started with 12,000, and I know now that my rate is 4.5%. And I'm going to raise it to the 6.5 power. So pause and go ahead and find that. Okay, and it looks like the population, and I'm going to have to round to whole people here, but it is 15,974 people. I did not round up because that is not a completed person. We're not going to be morbid or weird or anything about this. I have to technically round to the lowest integer, and that would be 15,974. Okay, last one we're going to do together here, and then all of the problems I think that I'm assigning you are going to be actually using the interest formulas, but these are good for us to get a good handle on how to start them. The population in an American city grew from 389,910 in 1987 to 524,000 in 1995. Find the rate. So since it ended at 524,000, but it started at 389,910. I'm going to have 1 plus r to the power of, and I have to figure out how many years have passed. And so if I look at this as my initial year, I have 88, 89, 90, 91, 92, 93, 94, 95. So that's 8 years. You can also get that from subtracting. And this, I'm going to follow the same steps. I'm going to divide, and then I'm going to take the 8th root, which I'm going to use the 1/8 power. And last, I'm going to subtract 1. So take those steps, pause the video, take those steps, and we will get there. Okay, so I came up with a 3.76%. Okay, and I'm going to use that to find that, which looks like it's 4 more years. So here's one thing you can do. You can use this amount and say, okay, I'm only going to go 4 more years. Or you can base your years, and then you just have to use the original amount. So whatever place you're going to start with. So I'm going to use the 524000, and I'm going to say 1.0376 to the 4th power, because I'm only going to say 4 more years from that point. But you can use this initial amount of 389,910 and then go 12 years from 1987. Totally up to you. And I came up with 607,366. Again, I'm not rounding up because it's not accurate to round up. So 607,366 people. All right, so number 23 here. It talks about a decline. So you're going to work with it the same way we did the last 2 problems, except we're going to be working with a decrease, which means you need to consider the fact that you're going to have the initial population, and then it's going to be 1 minus the r, and you're going to use that. So this is kind of anytime you see something that's going down in size or value, so you're going to be working with this. So you can go ahead and give this one a try. I think it's a good idea since you are looking for a negative r. So when you subtract the 1, you'll end up having to divide by -1 because you're not going to have a negative rate otherwise. So give that one a try. And then lastly, I'm going to introduce two new formulas to you. The first one is called compounded continuously. I'm going to define the variables with you, and we'll try two quick problems together. So here it is. The first one is A equals P E to the RT, and E is a number we talked about earlier, Euler's number. And then R and T and everything else is the same, really. So P is basically the amount that you're putting in. So it's going to be the initial amount. These are used for interest. So compounded continuously. I'll explain what that really means in a moment once we define everything. So this is your initial amount. In other words, if you were going to the bank and you were going to deposit an amount, this is how much money you bring to the bank. R is, of course, your rate, and you do want to change it to a decimal. T is the time. Typically, it's done in years. And A is going to be your after amount. It's the balance or future amount. So I'm going to write a couple words, balance or the future amount. Okay, so go ahead and write those down. Pause if you need to. Over here, it's compounded other units of time, and so I'll explain what that's going to mean. So once again, this is kind of your initial amount, so it's what we're starting with. Again, if I walk to the bank and I say, here I have $1,000 I'd like to put in an account, I'd like to save it, so that's your initial amount. R is again the rate, we're going to turn into a decimal. T is time, typically done in years. If time is given, for example, in half years, or it says 6 months, then consider that half a year. So time is 0.5. If it says it's a quarter of a year or something like that, just make the adjustments. Time is a year doesn't have to be 1. It could be a half a year. N is going to be the number of times compounded in a year. So number of times compounded, I'll explain, in a year. And then A, of course, is that after or that future value. So pause to make sure everybody has those things down, because the next part I'm going to give you is an explanation as to what N is, and it's probably one of the harder parts of all of this. The rest is going to be kind of just subbing some numbers in. So pause, please. All right, so the N that we have here, and you might want to make little side notes here, is N can be quite a few things. So compounded, you may think of like, well, stress is compounding, it just keeps building, or the homework is compounding, the teachers keep giving me homework, and it's like homework on top of homework on top of homework. Okay, so compounded interest is the same thing. So if you were to walk into the bank on January 1st and say, I'd like to put this amount of money in the bank, here's my money, and they say, okay, we compound the interest quarterly. That means 4 times a year we're going to give you interest. So the first time we give you interest, it's going to be on April 1st. That's after 3 months have passed. And the second time we're going to give you interest, it's going to be on July 1st. That means that 6 months have passed. And then we'll give it to you again on October 1st. That means that 9 months have passed. And then again at the end of the year, so let's say December 31st, because 12 months have passed. That means they gave you interest 4 times in 1 year. So N would be 4. So again, they're going to use the word quarterly, but that really means 4 times a year. You say, well, what's the big deal? Why is that important? Because if they give you some interest, and maybe it's not a lot of money, but they give you some interest on April 1st because 3 months have passed, then that means you get to start earning more money for the rest of the year on the money that they just put in your bank account. So it's not $1,000 anymore. It's $1,000 plus a little bit. And then when you get to the end of the next quarter, they give you a little bit more. So now you're earning money on money that they already gave you. If you just get interest at the end of a year, then you don't get to earn more money on that money until the following year. So it's better to have a compounding interest account. So now N can be a variety of things. Maybe it's weekly, which is really unlikely, but I'm just giving you scenarios. That'd be 52. Maybe it's monthly. Some bank accounts do this. That's 12 times a year. So you're not thinking like how many days are in a month or how many days are in a week. You're thinking how many weeks are in a year. It could be daily. And we do not use leap years, so don't ask about it. It's 365. We just go with it's daily. Bi-weekly would be, or semi-annually, or bi-monthly, or so there's different ways, but all of these are varieties of options. Now, how does that play into this compounded continuously? Well, compounded continuously is taking it a whole step further. It means that you are earning interest on interest before interest can even be added. It is like, it's so fast that it's being added to your account. It's instantaneously being added to your account, and you are always earning interest on interest that happened just a second ago. So it's just a rapid amount that's being applied to your bank, and it's not something you can even necessarily fathom. So let's give this one a try here. I don't want to take up too much time, but I see the word continuously, which means I'm going to use the A equals PE to the RT. Now I'm going to be replacing the R and the T and the P, and the E is just the number in my calculator. So we're going to substitute in our numbers to kind of make our little formula, and then we can grab our calculators. So I'm going to put $4,500 in the bank. E just gets written because it's a number, it's a base, like pi, you just write pi, so we're just writing E. And then I'm raising it to 6 times my 0.05, that's the time and the rate. So just be careful with your exponent, make sure that it doesn't drop out of the exponent when you're trying to calculate that, the power. So pause the video and let's give that a try. Okay, so I came up with, if we're doing this continuously, $6,074.36. Awesome. Okay, so the next one. Number 25 says you deposit $10,000 in an account, which earns, I should say which earns 8% interest compounded quarterly for 18 years. So maybe like when you were born, your parents put $10,000 in the bank, and then 18 years later, the money can be withdrawn. So let's go ahead and set it up, and I'm going to do after equals 10,000, and then it's going to be 1 plus, and here's where we're going to put the interest rate, and then N goes in two places. It goes underneath the interest rate because you're only getting a fourth of the interest rate each year. You're not getting 8% at each quarter, because that's an annual interest rate of 8%. So the whole year is 8%, but you get a quarter of it, but you remember, you still get to earn interest on interest, but you're not getting the full 8% each quarter. That's over the whole year. And then it's being raised to the 4 times 18 years because interest is being added to your account, not 18 times, but 4 times 18 times. Now be careful as you type this and just watch for your parentheses. So pause it, give it a try, and we'll check back with each other. So this $10,000 over 18 years at this phenomenal interest rate turned into $41,611.40. So I say just leaving that $10,000 alone for, your existence up till 18 years is probably really a good idea, because that might be 1 year of college. Okay, so let's keep all things the same, except that we're going to do it weekly. So I'm going to still do my $10,000, but this particular bank says, no, we're going to give you interest weekly. So that means we're still using the 0.08, but we're going to do it 52 times. So like on every Saturday at midnight, you're going to get this interest added to your account or something, okay? So that's 52 times 18. Go ahead, pause, and give this one a try. All right, so that one kind of yielded us a little bit more money. So the more often they add it, the better. So this came up with, I got $42,160 and then 28 cents rounding accurately. So just so you can see, like, that's how we're going to put them in. The problems that you're going to be assigned, which I'll tell you in a second, are going to be based mostly on these interest accounts ones. The reason I had you do the other growth models is because they're pretty basic, but they are important for you to kind of work through. And then we'll have a couple problems coming up to work on that involve just where the equation is actually given to you and you're just doing a substitution. So please give these a try so you can experience them, and then you can kind of look at the last page there. So, all right, you guys, I'm going to tell you that this is all done in splices, so I super apologize about even the length of it, but work yourself through it, give yourself the practice, and I will post answers to some of the bookwork, probably not until later tomorrow afternoon, I guess. I don't know. I will post it maybe sometime Tuesday, Wednesday. I'm working with a sick baby, so her naps aren't great, and I just appreciate you guys working through this with me. So you're going to hear me ramble in a second, and take care. Stay safe. Bye, guys. Which is page 429. It's actually the same section we did our last assignment in, and I'm asking you to try 71 to 79. I want you to do all of them, and then whenever I see you next, we'll get a chance to answer some questions on those. If I am out for extra days or something, you guys, I will write up all of my answers with some work and go ahead and post it to Schoology. I don't want you to not be able to check your work and to work through some of the concerns on your own. But I am asking you now to work together and to not be helpless, and try to do some problem solving. So none of this, well, I couldn't do it because you weren't here, because you guys are better than that, and you guys can do it, and you can work together. So have an awesome rest of your day, and I will see you as soon as I can see you guys.